Okay, so going through the definitions real quick, activation energy would be the amount of energy needed to make a reaction take place. Okay. Um, enzyme is a catalyst, means it speeds up reactions, and enzymes are biological catalysts, so they speed up reactions in living things. pH is talking about the concentration of hydrogen ions. Endocytosis is a type of vesicular transport that brings things into the cell. Endo means in. Exocytosis is vesicular transport taking things out of the cell. Exo, exit, going out. All right, facilitated diffusion is, it requires a protein for transport. That's the facilitated part, but it does not require ATP. Osmosis is movement of H2O across the cell membrane. Diffusion does not require energy. It's a form of passive transport. And the main thing for diffusion is that it's movement of particles from high concentration to low concentration. Epithelia, plural for epithelial, tissue that covers surfaces, lined surfaces. Simple epithelium means that it has just a single layer. Stratified epithelium has more than one layer. Inflammation. Repair and or replacing damaged tissue. Acid has a pH lower than 7. A base has a pH higher than 7. Plasma membrane is the border of the cell. Passive transport, as I said just a little bit ago, passive transport just in general does not require energy. That's the main idea there. Passive, no ATP needed. Active transport does require energy. It does require ATP. Okay. ATP is actually the cell's main energy currency. And ADP is formed when energy is released. So when we turn that ATP into ADP, energy is released. All right, so on to the questions. Which biomolecule consists of carbon, hydrogen, and oxygen in a 1 to 2 to 1 ratio? Anybody? Carbohydrates. Good. I was going to write on this. So carbs, carbohydrates. Number 2, which biomolecule class functions to store energy, provide insulation, and is a structural component of cell membranes? Lipids, yes, lipids. Good. Number 3, which class of biomolecules is directly responsible for a person's genetic makeup? Nucleic acids. Okay, which class of biomolecules can be a catalyst for a metabolic reaction? That would be the proteins. Enzyme fits in there, right? We're talking about enzymes, fits in the biomolecule class proteins. Which class of biomolecules consists of C, H, O, N, and P? Nucleic acids, yes. And the last one I can see on here, number 6, which class of biomolecules consists of C, H, and O, but not in a 1 to 2 to 1 ratio? Lipids. Okay. All right, moving on. Okay, what did you guys put for functions of the plasma membrane? What is it? Okay, so maybe isolate cell or protect cell. What else do we have? Anything else it does? So physical isolation, separating the inside of the cell from the outside of the cell. It is a barrier. A barrier does what? Keep certain things out, allows certain things to come in or go out. It determines what passes through, right? It's kind of like the gatehouse. All right, so it also controls exchange of materials. And it actually also provides structural support for the cell. So those are a few of the functions. Diagrams depicting a hypotonic solution, isotonic solution, and hypertonic solution, and indicate the direction in which water will move. So hypotonic. Let's do, I did it. So here's the cell, all right? Cell and the outside. And so I'll put some dots here, a few dots here. I'll put more dots here. All right, so the way I'm going to explain this is if this is the inside of the cell and this is the outside, okay, in this scenario here, more water is going to move in, because if you think about it, if there's less particles outside, then it means more of that volume is taken up by water, and water is going to move into the cell. This would be an example of a hypotonic solution. Okay, so hypo means less than. So if you think about hypotonic, you're talking about the solution outside the cell. Okay, and it means that there's going to be less dots, less solute. Okay, so that means we would have more water volume out there moving into the cell, which can actually cause the cell to enlarge, be what's called turgid, or if it's too much water, it could possibly even burst. All right, so now without changing too much here, I can, oh, I didn't even have to do that. If I switch this around now and say, let's say the right side is the inside of the cell, and the left side is the outside. So now the outside, the solution has more particles, so we would call this hypertonic. Okay? And in hypertonic, that means water will actually leave the cell, which can cause it to shrink. Okay? And for isotonic, the way I'm going to do that is I'm just going to add a few more dots over here so they're about equal. All right? So water will go out, and water will go in. Okay? Isotonic. Okay, so facilitated diffusion and active transport. I told you guys that whenever you see the word diffusion, that means it's passive transport. It does not require ATP. So active transport we know does require ATP. And so facilitated diffusion does not. However, they both will use proteins. Okay, that's why facilitated diffusion is facilitated. All right, so describe a process that cells use to move large molecules into a cell. Moving large molecules into a cell would be endocytosis. You can go through all that, but basically we have something come in, it joins the membrane, it's then going to form a pocket, stuff will go into, eventually that pocket will close off as it brings that stuff into the cell. Osmosis was actually one of our vocab words. And osmosis is referring to H2O specifically, to water across the cell membrane. In what situation could a cell shrink due to water loss? That would be when it's in a hypertonic solution. In what situation could a cell get larger due to water gain? That would be a hypotonic solution. Phagocytosis and pinocytosis. This is like cell eating. So it's bringing in solid materials, and pinocytosis is when it's bringing in a large bulk amount of fluids, cell drinking. All right, what class of biomolecules would most likely be involved in cell recognition? I noticed some people did get this one wrong. When I showed a picture of the plasma membrane, or I'm trying to think who did it in here. I'm trying to think what hour I had to show the plasma membrane. Might have been first. But we have these little chains of carbohydrates. And so when we have carbohydrates attached to things on the plasma membrane, we call them glycos. Glyco this, glyco that. If we have a chain of carbohydrates that's attached to one of the proteins in the plasma membrane, then we're going to call that glycoprotein. And if we have one that's attached directly to the plasma membrane, which hopefully you know is made up of phospholipids, we call those glycolipids. And I think about those, mainly what I stress about those is that they are involved in cell recognition. Kind of think of them as flags to signal that, hey, we belong here. Don't attack us, immune system. Number 16, how does diffusion affect concentration gradients in the body? It actually works to eliminate them. Doesn't always eliminate them, but it works toward that purpose if you think about it. Because if we have a high concentration in one area and a low concentration in another, and things are moving from high concentration to low, what's going to happen to the concentrations? Eventually, they're going to even out. The concentration gradient is the difference between the higher concentration and the lower concentration. We kind of think of it like a hill or slope, okay? And that's one way to think about diffusion. So diffusion, if things move from high concentration to low concentration, think of it as like the particles being a ball, and they're at the top of the hill. For the ball to roll down the hill, we don't have to keep adding energy. Okay, so it does not require ATP. The 4 basic tissue types, what are they? What was it? Muscle, I heard. Did I just hear connective? Epithelial and nervous or neural? Excellent. All right, the tissue through which gases are exchanged between the blood and the air in the lungs is what? No, so this is getting into, if we're talking at the surfaces, it's a certain type of epithelial tissue. And so number 18, what we're looking for here is actually that simple squamous, one layer of flattened cells. Number 19, the tissue that forms the inner lining of respiratory passages. For respiratory passages, I think of needing things to filter out particles that don't belong. And one thing that would work good for that is to have, say, like hair-like projections. So with the respiratory passages, I think of that really long, crazy one called pseudo-stratified, I'll put pseudostrat, ciliated columnar epithelium. Ochi dochi. Number 20 is talking about muscle tissue. What type of muscle tissue is voluntary? Is smooth muscle, is that voluntary? We can't choose to make our smooth muscles contract and relax. We can't consciously do that. What about cardiac muscle? Can we do it with cardiac muscle? Nope. Can we do it with skeletal muscles? Yes, we can. That's how we move. That's how we choose to move. All right, and where is cardiac muscle found? The heart. And what about smooth muscle? What would you associate that with? Internal organs. Yeah, and I think a lot of it with digestive as well. Not the only place, of course. All right, what type of epithelium lines the urinary bladder and many of the urinary passageways? When I think of the urinary bladder, I think of its ability to stretch and come back into shape. So that's going to be our transitional epithelium. Everybody good with that? There's just one more. Looks like there's more than one. Describe the process of inflammation. So we talked about that, repair and replace, damaged tissue. What are the three cell shapes found in epithelial tissue? What are they? Shapes. We can have them diamond shape, is that right? The three cell shapes found in epithelial tissue, we can have them flattened. What's that called? Squamous. We can have them cube shaped. What's that called? Cuboidal. And we can have them column shaped, which is columnar. Pretty easy. All right, large muscle fibers that are multinucleated, striated, and voluntary. If it's voluntary, it's got to be what? Skeletal. All right, so that's 26. All right, so we have to label some different types of epithelial, and apparently my diagrams aren't on here. Ooh, interesting. Okay, so I'm just going to say what they are. So number 27, do those look flattened? Do they look cuboidal? Do they look columnar? How many different layers of them are there? Just one. So if it's just one layer, we know that it's called simple. And they're column shaped, so columnar. All right. 28. Now, here's the thing about 28. If you look at the lower cells, they look kind of cube shaped. But as they get toward the surface, they're flattened. So that's what we want to focus on is towards the surface. So number 28, first of all, there's more than one layer, so it's going to be called stratified. And since the layers at the surface are flattened, we'll call this stratified squamous. This would be like our skin. Okay, 29 is showing it collapsed and distended, showing it really being able to be stretched. That's going to be transitional. 29. And 30 is showing one layer of cubed cells. So that's going to be one layer, simple, and cube-shaped means cuboidal. Cool. And 31 is showing those cilia. That helps us because we know that's the one, the long, crazy word, pseudostratified, ciliated, saying that there's cilia on them, and they are column-shaped, so columnar. Pseudostratified means fake stratified. Looks like more than one layer because of the different levels of the nuclei, but it's not technically more than one layer. All right. So then we have the last one, 32, which 32 is showing one layer of flattened cells. So 32, one layer would be simple, and flattened cells would be squamous. So easy for filtration to happen there, just moving across one layer of flattened cells, diffusion of gases. And then the last one, so we've got some different classifications of connective tissues. So this is what you really need to know. Connective tissues, when we talk about this stuff, we have our epithelial tissue lined surfaces. We have muscle tissue, which is muscle tissue. We have neural tissue, which is neural tissue. And everything else is connective tissue. I almost consider connective tissue to be like the filler for the rest of our body. But there's a lot of different stuff involved with this. But if you remember these things, you'll be okay. First of all, we can have loose and dense connective tissue. So an example of loose connective tissue, we would see fat. Dense connective tissue would be like tendons and ligaments. Okay. We can have fluid connective tissue. Okay. Fluid connective tissue, if you think of the fluids in our body like blood and lymph. And we can have supporting. So supporting is going to be strong. So we can think with supporting connective tissue, bones are strong, give us support. And along with bones, a close relative, cartilage. And that covers everything you need to know for the connective tissues part at the end. All right. So that, bleep, 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 that's all, folks.